Yeah. Hello everyone. Hello everyone. Good morning. Hope you all can hear me.
Good morning.
Hi, Lokshay sir. This is Prakash from Star Agent. Can you please make me co-host?
Yeah, sure. Sir.
Thank you, sir.
Yeah,
Thank you.
yeah. Thank you. So I can see still people are joining. We'll give another minute, one more minute, and we'll start the session, guys. In the meantime, if you have any queries, please let me know. So, any questions, guys, before we proceed? Yeah, no problem. Hope you all have it right. Okay, thank you. All right. So, did you get a chance to practice it, or like, what is the progress?
Yes, for yesterday's session, I had gone through the Docker commands that you posted on the text.
Okay. All right. So, let me bring the screen. Okay, let me log into your instances now. So you're able to install and configure the instances. Everything is fine, right? There's no problem. You can able to run the containers, port mapping, everything is working as expected, no? Did we talked about Ansible? Yes, so that is also part of your document. I think I have created a separate document for you there.
Hi, Sai. I have a doubt, somewhat confused in that port mapping alone. Everything else is fine?
Okay, what's the doubt there? What's the question?
The port mapping,
Okay,
that topic alone, I need somewhat more clarification.
yeah, no problem. We'll do that.
Okay, thank you.
So we have installed Docker in our slave machine. Docker, right? Okay. And we are done with all things related to your volumes and basic things are done. We are here to create an image, right? So your question is about your port mapping, like how we can able to map the port for the application that's running inside the container. This one, right?
Yes,
Right.
yes, yes.
So this one, right? Okay, sure. We'll talk about it. All right. So let me get into this first. Where is it? Okay. Okay. So I think this is a server, right, which we're using yesterday. Sure. All right. So the point is, if you're talking about the applications that are running inside the container, like I have a container called Tomcat container, which is used to run some web applications. And whenever you run any web application inside the Tomcat container, by default runs in port 8080. That is a basic property of Tomcat port, right? So now the point is, the application is running inside my container, and the scope of that application is within the container, because the container, whatever we create or execute, it is having the isolated environment. It is going to get executed in a completely an isolated namespace, and even the underlying operating system also will not have any clue about what is happening there. So now the requirement is the applications which we are running inside the container, you want to access it through web browser so that end user can able to access it. Okay, if I have a VM, in that VM I have a container, and in this container I have an application. One application is up and running. It's a web application. And this scope of this application is within the container. Got it? Because it is completely isolated environment which is running inside the container port. Now, how I can able to access the container at the VM level? Because only if I can able to access the container at the VM level, I can able to expose it to internet, and any end user can able to access it through my browser. So in order to expose your applications to internet, all that we do is we just do a port mapping. So while running the container itself, you'll be using the publish option. You're going to publish your container port with your host port. So this 8080 is something within a container. I want to access my application through the host port number 8089. It is something like creating a link or mapping your host machine with your container. Have you executed this, got the result, or you're ready to execute?
No, I haven't tried yesterday. But in this topic alone, like I have gone through this recording again. I got some. Yeah, the
So
port map, the host map will be anything, right? Any port number we can use,
the
right?
host port can be anything that is available,
Okay, okay,
but the container port is always 8080. That's what we have used, right?
okay. Okay, to publish, we are using this port mapping
Yeah,
to the outside world.
yeah, that's right.
Okay, good.
Sai, there would be one query. Let's say if we have two containers, right? And um, if user requests something for the application, then it comes to the host port, and from the host port, it will be redirected into the application that reside in the Docker container. So how can it would be accessible uh, between containers? I mean, let's say if containers have to be linked, or like
Yes.
how we can say.
Yes. So in the case, a container network will be created. Using the container network, you'll be using the port numbers of the container to communicate.
So we can use that, I mean, container port, or
Container port. Using
okay,
container port only, you can able to access it.
okay.
So this port number. Like yesterday, I was talking about this process, right? Whenever we try to run more than one container as a single service, in that case, these three containers has to communicate between each other, right? Front-end container will share the data to container 2, and this will be sharing to container 3. So this process will be enabled by using the port numbers of the container. Got it? So when you execute all these things as a service, everything will be under a single network. Got it? It automatically creates one network. We have a concept called Docker Compose. Using Docker Compose, we can able to run multiple containers as a single service. So what are the containers you want to run? The content definition will be given in the Compose, and you can able to interact between the containers just by giving a local host followed by the port number within that network. It's possible. We'll talk about, okay, tomorrow we'll work on Kubernetes and what do you call that? Something related to your Docker Swarm. I'll talk about it.
This port mapping would be beneficial if in case as Docker is containerization, I mean containerized method. So if in case this container would be down, and someone wants to access this application. So, link, if any other container or new container would be created. So in that case, that application would be accessible from that container, right? From the new ones.
Yes, that is what we call it as container orchestration.
Okay.
Yesterday, I think we talked about, right? Using
Yes.
Kubernetes and Docker Swarm. This is just to ensure high availability of the containers, right? So even if one container is down, it will automatically create a new copy of the container, and with the same entity, you can able to access it. Only the port number, I mean, the IP address might be different, but apart from that, it can resume from where it left.
So this IP address is like whenever the container is created, so IP address that belongs to that specific container only, right?
Yeah, that's right.
Okay.
Okay. So now we are on day 8 of our session. Sorry. So today we'll see how to build an image, to build Docker images. So, and then we'll have an overview of Docker Compose, Docker Swarm, and then we'll be getting into Kubernetes. Okay. I think yesterday we discussed about volumes, right? That's fine. So because this Docker Compose and Docker Swarm, that can be very much effectively done through Kubernetes. So we can't split Kubernetes here. Okay, whenever we talk about Docker, it is always recommended to have a knowledge in Kubernetes. That is what the current requirement. Got it. And even in the future, if you want to specialize on any of the DevOps tools, Kubernetes will be the right option for coming futures, at least for next 5 years. You can focus on Kubernetes. Definitely, it will add value to your profile if you want to really specialize. So as far as this training is concerned, we're going to have the fundamentals of Kubernetes and the fundamentals of Docker modules. So once we start with Kubernetes, I'll be showing you how we can able to orchestrate, how we can able to combine more than one containers, how to run multiple containers, how to deploy it, how to ensure high availability, all this stuff. So in order to work on Kubernetes, first you should understand the architecture of Kubernetes. Okay. So once you're clear with this architecture, then we can able to take it further. No problem. That's fine. Yeah. So now we'll see how to build the images or how to create images. So far, what we are doing means we are just trying to pull the images from Docker Hub and trying to run those containers out of it, right? So going forward, what we are planning is we are trying to create our own images because that's what expected in real time also. Yesterday, while talking about the use cases on development and deployment level, I was talking about the image creation, like how we can able to capture the dependencies of an application and create an image out of it. So this is what we usually do in real-time environment, and it's all completely taken care by the developers. It's the response of developers to create the image. And the definitions, whatever required for the image creation, everything will be maintained by developers in the source code repository. So with that information, we can quickly launch or access the server, and we can able to manage your applications at any point of time. So for accessing your, what is it? So Docker images can be created with two options. One is by using Docker commit command. It's very important for interview also. Please stay focused. Docker commit and then Docker build. So these are two options available, which is used to create the user images, application images, or any container image. So if you're using Docker commit means it is a process of creating image based upon the existing container. Let's say, for example, consider I've used a Docker run command in an interactive mode, and I've executed CentOS image. So now the control will be inside my container, and I can able to install all the required tools like Git or Maven or JDK or Maven, something like this. And after installing all these tools, I have Git, JDK, Maven will be available in the container. And with this container, I can able to clone the repository. I can able to clone the repository, and I can able to perform some stuff build. Everything is possible now, right? But once I exit from this, what will happen? Once I exit from this, what are the tools I've installed inside the container? Everything will be lost, because when I run the container again, the same image, I won't get the tools in the new container, right? Whenever I run the command, when I issue the run command, it will try to create a new container, and in that new container, it will start from the scratch. Again, I have to go and install all those things. If the container is in my same machine, I can quickly go and start it. If I start, it will resume the process. That's not an issue. But in real-time environment, the container will be created in one machine and it will be used in another machine. Like in a dev server or build server, you'll be creating it, and it has to be executed in QA server. So it is not possible to copy the container from one machine to another machine, because containers are the executable unit. So assume that I have created a container which is having a Git tool. How I can take a backup of this container? For that, what I can do means I can simply use Docker commit command using the container ID. Using an ID, I can able to create a new image. So now this image, it composed of all the components what you installed in this container. And this image can be published to your Docker Hub, and from there you can able to pull it to the target machine and start using it. Are you getting the workflow? This is the purpose of Docker commit, right?
Yeah.
So it's very simple. Run the container, install all the required tools, and you can exit from there. If you want to reuse the container, it is reusable only within a machine. Like you can use your Docker start command, you can start it again. That's possible. Yesterday we discussed Docker start command, right? Remember, if you start the container, it just start it again, and you can able to make use of the existing properties. But if you want to share it with your team members, or if you want to use it in the future, it's not possible. For that, we have to convert that container. Okay, we have to create a new image out of the container, and that image will be published to Docker Hub registry, and anyone can able to pull that image and start using it. That is about Docker commit. And the next thing is about Docker build. So this Docker build is completely from the scratch. I'm not running any container, or I not install any tools there. I'll be building my own image without any container reference. So for that, we need a Docker file. So in this Docker file, we'll create the definitions. Definitions means yesterday I was talking about the Docker file, right? It composed of, image, right? Image is composed of various layers. So what are the properties? What are the layers that is required to build your image? Everything will be defined here. And once the Docker file is ready, the Docker file can be published or used to build your image. So Docker build followed by the Docker file name, or you can say like image name, and then your Docker file name. Correct. So this also will create a new image. So both Docker commit and Docker build is used to create the image. Basic differences: Docker commit needs a container ID as a reference to create a new image. But the Docker build doesn't require any container. Directly with the help of the Docker file, we can able to create a new image.
One doubt, sorry. We are giving the Docker commit, right? After performing all the tasks, and if we have a perfect a kind of all the prerequisites, then after at the last time when we are going to exit, at that time we have to execute that commit command.
No, once you exit from the container, this Docker commit
Okay.
should be executed from the host machine, not inside the container.
Okay. Okay,
Correct?
with the ID. I mean, image Docker
Yeah,
ID.
container ID. Hope you are getting this point.
So once exit, how can you say that? I mean, how can we say that the tools installed on this Docker container would be preserved, or because as per the rule, like the exit command would uninstall all the tools, right? I mean, we don't have anything in Docker container.
See, we have something called Docker ps-a. What it mean here? This will get the list of containers that are in stop state or exit state, right?
Yes.
So it matters. So this container ID already available. So if you give a start command again, it will try to start the container with the same property, whatever you have there. And it will be available in a machine till you delete the container or you kill the container.
Okay. Okay. All right.
Correct.
So delete command would, I mean, destroy
Yeah,
everything.
not delete command, remove command. Instead, use remove, right? RM command.
Okay.
Remember?
Yeah.
So with that, we can able to remove it.
Okay.
So now what I'm going to do here is let me create
Sorry, one quick question. Can you just give example? Where do we use Docker commit and where do we use Docker build?
Yes, that's what I told you here. In this case, if you noticed, whenever you want to create a new image based upon the existing container reference, I already have some containers, and based upon this container, I just want to create a new image. In the case, you'll be using Docker commit. But assume that you don't have any container reference. You want to start from the scratch with the Docker file. In the case, you'll be using Docker build.
Got it. Thank you.
So the basic difference is to execute Docker build command, you need a Docker file. And for commit, you need a container ID. Easy?
Sure. Thank you.
Okay.
Okay, whenever we are going to exit from the OS, I mean, that is which our that OS, then only it will be erased everything. Like we lost our data, right?
Your voice is not clear, first of all. And if I'm correct, you are asking about exiting from the container, right? Not from OS.
Yeah. Can you tell about like when it will be lost? The container. From which one we have exit? Like that will be lost.
It can be anything. Like I started a container in interactive mode. I can able to perform a number of activities there. Once I'm fine with all the activities, I can exit from the container, right?
Yeah. Okay.
Correct. At any point of time, you can able to exit from the container. Let's say, for
Yes.
example, I log into one container and install Git. Once installation is complete, I can exit from the container. It's possible.
Okay. Yeah. Then we will be losing the data.
Yeah.
Okay. Then we are using the volume, right? Only for the files we are using the volumes for the backup.
Yes, it is just to maintain the data, persistent data of your containers.
Okay.
It is not related to container or image creation. That is different. That is a completely different one.
Okay.
So now let me show you how to execute this Docker commit first of all.
Yeah.
So I think we have some images, right? Like if you want, I can try with some different image also. We have Docker Hub. So already we worked on some Ubuntu related things. Let me check if we have any other options. Like Debian is there. Yeah, Debian OS. So this is also another family. Okay, I'm just giving some reference. That's all. So we have this. So let me try with some command like Docker run -it Debian. So Docker run -it Debian means it is just trying to download this image from Docker Hub and run it in interactive mode. If you want, you can use the Ubuntu or your CentOS, anything is fine. So now the control is inside the container. You can see here. There is one container up and running with the Debian image. So what I'm going to do here is I can able to get the file system. I can able to check for the Git version if it is available or not. No, Git is not available. So what I can do, I can simply go and install Git here. Let's say if I want to install any package, first let me update the package. apt get update. And then I can say apt get. We can install git. So I'm installing Git inside this container. And once the installation is completed, I can able to verify the version now, version of Git. It's available. It's just an example. Like this, how many tools you want to install, you can able to install as much as possible for your application build server or a test server or any other deployment server. Once it is done, you can simply exit from this if you wish. Okay, let me exit from here. That's it. Now, if I say docker ps-a, I should able to see the latest container got executed with this container ID. Now, what I can do means I can simply use a command called docker commit command. Before that, images. You can see there are 3 images here. Now let me execute a command docker commit -m. Sorry, no, -m. Docker commit container ID. Based upon this container ID, I want to create a new image, right? So just basically container ID and give a name of the image which you want to create. So let me say like locusci eta / I want to create a image like let's say rt with Debian Git. And if you want, you can able to give some tag also here, 1.0, something like this. So what we're going to do here is already I have a container. Based upon this container, I want to create a new image. And I'm just tagging it with 1.0 as a version. If I'm not using this tag means it will assign a tag called latest. If you want, you can give some tag, something like this. You see? So now it will try to capture this container and try to pull all the required details from the container and try to create a new image out of it. So now if you see here, a new image has been created. Doxa ETA SARD Debian Git. Now, whenever I run this image, let's say git, sorry, what is it called? Docker run -it :b 1.0. Whenever I run this image in interactive mode, I can able to see git is accessible. Clear? So I don't want to have a new image and install git for each and every execution. I have created an image based upon this previous container. The container is already having the git installed, so I can able to make use of it here. Easy? Are you getting a point? Guys, is it clear or not?
Yes. When we create this image, when we create the container from this image, we have to specify the name of this image along with the tag.
Tag means it is always recommended to have a tag. As a best practice, we use tagging, but it is not mandatory.
So by default, it takes the latest one, right? If you don't specify it.
Yes, that's
Okay.
right.
Yes, we went to this new image, right, which we just created and renamed. Some of the operations we used to perform, and this automatically will save in the same container, right?
I'm not getting you. Like, what is it?
We just renamed and created new Docker container, right? A new image, sorry.
Mm-hmm.
Okay. If we performed any operations in this new image, like,
Okay.
will it be saved or
No, it won't
it
get
will be
saved. It will, when you try to create a new image, you'll be running that container, right, based upon that image.
okay?
And in the container, what are things you're doing? It is applicable within the container. If you want to
Okay.
save it again, you have to create a new version of it. Use again Docker commit and create a new image out of it. That is what the incremental change is.
Okay.
So the very first version of that image is having a git, and in the next execution, you made some more changes. You can create a new version out of it.
And we have to save as a new image. Okay.
Yeah, that's right. So why I should create a new image out of it? Why can't I directly run that container itself? It's possible, no? I have a, let's say, if you can see my screen here, I have something called, wait, can you able to see my screen or not? Docker images. So, and if I say Docker ps-a, I have these many containers, right? The container, whatever I executed, and based upon the container, I created one new image, and based upon new image, I just created one more thing also. So this was the initial container which where I've installed Git, right? Hope you remember.
Yes.
Just to differentiate, I use a different image because if I use CentOS or something, it might confuse. So that's the reason I use a Debian image. And now in this container, what you can see, already the container is in stop state. I can say like Docker start followed by the container ID. It started. Now if I say Docker PS, I can able to see the containers up and running in a bash mode. Now the point is how to log into the running container. I want to explore what it is actually there. I want login means I can say Docker exe command -it followed by that container in bash mode. See, I can able to log into container. Now if I say ls or if I say git version, I can able to see in this container which I exit earlier. I've already installed git and I can able to restart the container And when I log into the container, I can able to see that particular version of Git installed already. So the point here is within your local machine, you can able to run the container, install the required tools, and you can able to restart it at any point of time. You can able to log into the container at any point of time. There's no problem. For that purpose, you no need to create a new image. When we need to create a new image, when we'll use the Docker commit means if you're done with your work and if you want to share this work with your team members, or if you want to take a backup of this image or this container, because everything in local machine, right? If you want to share it means you need to put it in a common repository. That's what we call Docker Hub registry. So in the case, you can't directly copy the container Docker registry. It should be saved as an image. That's the reason we just build a new image out of it. Are you able to understand the scenario?
Yes. So in that case, if from this previous container, we executed Docker commit command and created the image, right? Now that image ID, let's say it's ID with A. And now from that image, if we run that image and create a container and install, let's say Maven or Tomcat, now from that Docker container, again, we create the same image or the new image.
New image,
So
new
that
version.
image, so that image would ID would be same or it will be changed.
That's what ID can be same, but version can be different. A new version can be created.
Okay.
That
So
is what. See, even if you noticed here,
yeah.
in your repository and all, you can see there are a lot of tags here, right? It's all versions, the incremental changes, whatever you make. So whenever you want to make incremental changes, you can able to have it with a different version number. Let's say this is a Debian. Docker pull Debian is the image name. Debian is the image name, but this is the version. So whenever you make any incremental changes, it has to be tagged with the proper version number, and image name can be saved. That doesn't matter. That's the reason I just added V1 here.
Yes, got it.
Hope things are clear. Okay. So now you understand two things here. It's not just about Docker commit. If you want, I can put the syntax here for a commit. And you should also understand about the purpose of exec, right? Docker exec. Remember, for the container ID. So you can able to start the container. And once the container is up and running, if you want to log into the container, you can able to use Docker exec command. So using each command, you can able to run in interactive mode or anything. So there is a basic difference. Already we discussed about Docker run command, right? And now it is exec. So even using Docker run also, we can select Docker run -it. And also we have Docker exec -it. So what's the difference between Docker run and exec here?
Docker run generally is used to create a container from the image, and Docker exec when we want to log in into the container. Or is that something?
Yeah,
The
that's right.
exe
So
is
whenever
when
we
uh,
yeah, go ahead, please.
the exe is whenever the container is going on, it is active. Whenever we want to log in while it is running, we used to use exe.
Yes.
Or if it is in stop state, we use run.
Yes. So whenever you try to create any new container based upon the image, you'll be using Docker run command. It will create a new container, run it. But exe is used to log into the existing container that's already now running state. If a container is in stop state, you can't use exe command. So exe is basically used to log in to a running container. That matters. Hope you can understand the difference here.
Yeah. And -t in that build terminal. Okay.
Terminal. So now that we have verified the results of Docker commit, and you should be able to see how to commit the new image using the existing container ID, right? So you have the syntax here. You can refer the same syntax if you wish to have here. What we did, a lot many things. Okay, here's an example. And next we'll talk about the Docker file. So Docker file is something very much important, okay, because in real-time environment, no developers will create the image based upon the container definition. It's all done by the administrators, system administrators or the Docker admin or the infrastructure team who wants to mimic the existing server and create a new image. They can able to do that. Even in your what do you call that AWS, while launching the instance, you're choosing AMI, right? What is it AMI? Amazon Machine Image. It is a kind of image actually. Technically, we call it server templating. So using that image, we can able to launch or create a VM. That much capable it is having. It's just a OS actually, correct? So which image you want to use on that based upon the image, a VM will be allocated. Similarly, here also, as a developer, they can able to create some applications, and that applications can be packaged together and create an image. That is one case. But apart from that, as a system administrator, let's say I'm just talking on infra perspective now. So as an infrastructure perspective, right, what you can do means consider there is one requirement to create or to configure my web application server for testing. Okay. My requirement is to configure the web application server for testing purpose. So, scenario is, what are the tools required to configure the web application server? If it is a Tomcat, means we need a JDK and then Tomcat. If it is Nginx, means you can simply install Nginx and use it. So now that I want to run this in a container, so what I'll do, I'll be using the base image, Docker run -it. I can able to use a base image, it can be like Ubuntu or Debian or CentOS, whatever it is. And when I execute this command, what will happen? The control will be inside this particular container. So I can able to install JDK and then install Tomcat. And after installing Tomcat, I can able to expose to internet. That is exposed to port 8080, right? And then I can able to start Tomcat. So these are the various commands that I be executing in this container. And I can able to see, once I execute this thing, I can able to see the Tomcat is up and running using port 8080 inside the container. And I can able to use some port mapping to make it possible, make it up and running. That's fine. So now the point here is, once I'm done with the work, upon testing the application, if I simply say exit, it will exit from the container, but I'll be getting the container ID. Correct? From the ps-a list, I can able to get the container ID. So this is done for my current requirement. In the future, if any of my team member wants to achieve the same task, I don't want to again repeat the process. So what I do smartly from infra perspective, what I can do means, once I'm done with this work, and if I'm sure that this work will be utilized or done by the other team in the future, on in order to reuse this capability, I can simply use the container and create a new image out of it, like using Docker commit followed by the container ID. and the image ID or image name. Image name I can say like Tomcat server image. That's it. Got it. That's it. So now this image will be available and I can able to publish to my Docker registry. So down the line tomorrow, if any other team are coming for the same requirement, means I don't want to start from the scratch. I can directly have an image and I can allow them to run the image at any point of time. Easy. Are you understanding the scenario? Like how we work in real time with these Docker commits and all?
Yes.
So this is at the infra perspective. Now, on the other hand, if you're talking about the developer's perspective or a deployment perspective, developers or deployment team, they never concern about the content. They never install all these things. They are just the consumers, right? So they just try to utilize it. Let's say if you give them an image, they can simply run the image. That's all. Within the image, they won't go and do all sort of installation. It's not their role actually. So on developers perspective, what we can do means we can able to package the application artifacts. On development perspective, we can able to package the application artifacts and that application artifacts will be packaged along with the dependencies. So to do this, they'll be creating a Docker file. So what this Docker file is going to have means it is going to have some set of instructions. Create the layers of image. So developers, they'll be writing Docker file because only they know which application they want to build or package and what are the dependencies for the application. Only they are aware of it. So we'll allow them to create Docker file. Only thing is through Jenkins, we can able to automate the process of build and deployments that we can do. So how to write a Docker file? What is the instructions all about that you should understand now? So if you take any example here, you can consider anything here. Like if I want, I can take the latest version of this. So now, if you look into the images here, it is having two layers. One we call as the add command, another thing is CMD. So this is what the instruction looks like. Or if you explore something like Tomcat, go to the latest version of this image. So you can able to see this image is composed of various layers, which is having some instructions like copy instructions, CMD, ARG, ENV, all those things. These are all some instructions, correct, which are used to create various layers of images. So Docker files are just composed of these many layers. Those layers are created by using the instructions like this. So I'll just give you a quick example, like what are things we achieved here. Let me get into this. Docker PS. Now, what I'm going to do here is I'm going to create one new image using a Docker file. So all that I can do is I want to create a folder. I don't put it here. Let me create a separate folder here. Docker contents. So, okay. And cd to that content. And now I'm going to create a file, Docker file. File name should be the same. PA Docker file. The file name should be the same. And go to insert mode. So what are things we did so far? Like for example, I just use a base image called Debian. Right? I use a base image called Debian. And what else I did? I just executed apt get module earlier, right? that can be done with the help of a run command, run instruction. Run apt get update. Run apt get update. Similarly, run apt get. You can able to install git -y. Or if you want to install any other services, you can give all sort of things by using the run instruction. So whenever we try to create any Docker file, the Docker file should start from the base image, like Debian image or Ubuntu or which OS you want to refer. Based upon that image only, we can able to build the layers. So in order to capture the existing image, we'll be using a from instruction. From instruction is used to populate the base image to your Docker file. And on top of that base image, you are trying to add two more layers, like updating the package and then installing Git. So once you're done with the definition, we can simply save this file. So now that we have saved the file, once the file is ready, all that you can do is you can simply use your command called docker build command, docker build -t followed by the image name, like sa rd debian, or I can say like debian git 1 : s 1.0, like this. I can add a command and the commit details. So this build command, it uses this image, and in this terminal is going to create the image ID, and it is going to refer the Docker file that matters. So the dot represents the relative path of the Docker file, whatever you created. So always we execute the build command from the path where you have a Docker file. So if you run this command here, you can able to see it is interpreting the file, and it has update the package and trying to install Git. And now based upon that, it is create one new image. And if I say docker ps-a, there is no container executed, but if you see here, the image list, the new image has been created. Latest image is Debian Git 1 with SV 1.0. And as usual, I can able to run the image like docker run -it followed by that image name. And I can able to explore what are things we have mentioned, everything is available there. So there are two options. Either you can edit the existing container, install the required tools, and create a new image out of the container ID, or from the scratch, you can able to create a Docker file and maintain all the instructions of the Docker file. Let me show you the instructions here. This one. Okay, this is what the content of Docker file. Once a content is ready, you can simply issue a command docker build command to build that image. Are we good with this? Any question?
These keywords from and run, I mean, commands are case sensitive. I mean, we have to type in capitals or
Yeah, it's case sensitive.
okay. This file we can save in any format, right?
File name should be exactly the same as per the process Docker file, because when you run the command, right, we're not giving the file reference, we're just simply giving a dot. So the Docker engine will try to search for the file which is saved as Docker file. Decaps.
Yeah, so we don't need to give, I mean, when we build this image from the Docker file, we don't need to give the file name, right? Just
No
simply
need,
put a
just
dot.
yeah, dot, that stuff.
Okay.
So in real-time environment, developers will maintain such Docker files along with source code. They just publish it to the source code repository. Even the repository, whatever you have already for Jenkins module, if you explore the repository, you can see there is a Docker file present. So the Docker file is composed of the application artifacts, whatever we have. Easy? Are we good with this? Any question in Docker commit and Docker build? Yes, are we good to proceed or do you have any questions here?
You can proceed.
All right, so please try to understand the difference between the build command and the commit command. So build will always refer the Docker file. Your commit will refer the container ID. That makes the difference here. Okay, that makes a difference. And developers' responsibility is to maintain all these Docker file in their source code repository. We never create all those stuff. It's all done by the development team. So any other questions, please let me know, guys. Are we good with this? But as a DevOps engineer, you should know what are the various instructions, at least what are the frequently used Docker instructions we define in the Docker file. That's something important. As of now, we use something called Docker, what is it called, from command, and then something like a run command, right? So that's what we've used so far. But apart from there are a few things that should be considered. So I can give you one quick reference of that also for you to understand it better. So where is the document? Okay. So you can consider this, okay? These are the frequently used instructions that we use in a Docker file. We have something called from instruction, run instruction, copy, cp, work directory, env, expose, cmd, and entry point. So these are all, no, even for interview perspective also, these things are important. So always the from instruction will be used to specify the base image. As we have seen here, using from instruction, we just specify the base image. And the run instruction used to run some package manager to manage a package within the container. So let's say I want to update the default packages or I want to install the Git package, I use run instruction. Correct? And the copy instruction that is used to copy the files from your host machine to the container volume. Like remember last session we discussed about something on volumes, how we can transfer the file from your host machine to the volume, container volume, right? Similarly, consider a scenario. I have a slave machine, and in the slave machine, I have a war file created. As part of the build, the war file is created in the target folder of my slave machine. And now I want to copy this war file to a container volume so that it can be executed in the container. So to do that, we use a copy instruction. Copy will use to copy the file from host machine to the container volume. Similarly, there is another command called cp command. CP is also refers to copy, but difference is the cp command is used to copy the files with the container volume, that is within the container volume or directory. That means within the container, if you want to copy the file from one path to another path or from one directory to another directory, you can use cp. Hope you understand the difference between copy, COPY and CP. COPY is used to copy the file from host machine to the container, but the CP is meant for copying the files within the container volume from one directory to another directory. So I'll show you, okay, tomorrow while working on that actual CSD pipeline, I'll show you how we can able to use the WAR file that is created in your slave machine and create a new image out of it. And then we'll see how to copy the instructions within the Docker file. And work dir, that is used to identify the current working directory. Like consider I want to copy my WAR file to the container volume. Where this WAR file is present, what is the directory? That will be defined by this work dir. And then we have something called env that is used to create the environment variables. This environment variable, it is used to define some properties of the tool, the installation path. Hope you remember, I was showing you something on your Docker, right? Sorry.
Tomcat.
Yeah, Tomcat here. So if you look into this Tomcat image, we have something called CMD, ARG, and env. This is all used to define the environment variables of JDK. Similarly, work directory. The Tomcat default work directory is user local Tomcat. And from this directory only, it just interprets and takes to the next level, like bin folder or something like your web apps folder, everything. And then expose command or instruction that is used to expose the container port, like based upon which port you want to use. Let's say this container image, Tomcat container image, by default is running with port 8080, means that is because of this parameter. If you want to change the port of that image, you have to create a new Docker file out of it and change the port number. That's possible. Okay, so like this, we can able to define a lot of parameters for the container and its image properties. And then if you noticed here, there is a last instruction line number 19 that is pointing to CMD. CMD means it is running some script actually, right, to run your Tomcat server. So basically CMD is used to execute some commands. So the commands, whatever you're going to execute, that is considered startup command for that container. Let me have a definition here. I have this particular image with the command like catalina.sh. This is a script that is used to start the Tomcat server, right? So whenever I issue a Docker run command, this command also will get executed and it is automatically starting the Tomcat server. So this command, whatever is specified, consists startup task or startup command for that container. That's what. So CMD instruction used to specify the default or startup command to run the container, and this allows users to pass any commands at runtime. Like when I was executing something like, even in this demo also I was showing something, right? Docker run CentOS. If I simply execute this container will go to exit state. If I say Docker ps -a, I can able to see we are just execute this container based upon this image by using a default command called bin bash. Bin bash is the default CMD. So if you search for that image, CentOS, or you can able to get it from the history also. From the history command, we can able to see that. See, the last executable command is bin bash. So this command is what getting interpreted and is not having any task to execute. But now what I can do, I can simply say sleep for 20 seconds. Remember? Hope you remember this command yesterday.
Yes.
So what are you trying to achieve here?
This container would run and sleep for 20, so we can't execute any, I mean, no commands would be executed till 20.
No. That is not the point here. Here, the point is, by default, the container is defined with this CMD, bin bash. Now, I'm trying to replace this command by using the parameter sleep 20. Now, if you say docker ps-a, earlier it was running with the default property, default command which is defined in the container, right? But in the latest execution, it is using the value whatever I passed at runtime. So that is the reason why they define the container with the CMD argument. CMD means it is used to pass some runtime commands, and this command can be changed at runtime. That's also possible. So end user, whenever they try to run the container, they can able to give their own commands or instructions that will be replaced there. You see? That's what I was telling here. So this allows the user to pass any commands at runtime. You see? Guys?
Yes.
See what happened?
We have just one Docker file. Now, from that file, we are going to create the image. So now let's say we want to create not just one, just a couple of images. So we have to modify that Docker file again and again.
Yes, we can modify.
That's the only option. We can't create any other one, right?
You can create a different directory if you want.
Okay.
Got it. So now if you see, we are allowing the users to pass their commands at runtime, correct? Using CMD, we can able to allow the users to pass the commands at runtime. So due to some issue, like for example, while the user gives the command, if the command is invalid, what will happen? It will fail the execution, right? Correct. That's what happened here also. So
Yes.
if you don't want to allow the users to change the runtime inputs, you can able to use the same command as the entry point. So both commands CMD and entry points are used to specify the default values as a startup command to run the container. I repeat, both CMD and entry point are used to specify the default values or any startup command to run the container. But the difference is your CMD will allow the user to pass any commands at runtime. We can able to change the commands at runtime, but the same command if you given as the entry point means that command cannot be modified. It will not allow the user to pass any commands at runtime. That makes a difference. Easy? Are you getting your point?
And the syntax would be same, right? Entry point and CMD.
Yeah, syntax is same. Instead
Okay.
of CMD, it will be like entry point followed by the syntax. I mean, the options, whatever you wanted to pass.
Okay.
Yeah. So that is about your instructions, basic instructions that we have in our real-time environment. So tomorrow, while working on our application image creation with the user, with the actual artifacts, I'll show you how to use a copy instructions and other stuff with the demo. All right. So this is all about creating your images, user-defined images by using Docker commit and Docker build command. So now that we have an image ready, what next?
We run the container. I mean, create the container from that image.
Yeah, that is fine. That is what we did actually. Even if that is your intention, you don't need to create an image also. You can directly use Docker start command to start it again, right?
Yes.
The basic purpose of creating image is to share it with the users, publish to Docker Hub registry, so that any other user or even in the future, if you need, you can able to access from there. So the next activity is publishing the images to Docker Hub registry. So in order to publish the image Docker Hub registry, first you need to understand about the Docker Hub login process. So if you want to log in Docker Hub, you should have a valid user ID and password, right? That is done through your browser. But apart from browser, if you want to access your Docker Hub account or any account going forward, if you want to access through your CLI or from API calls, you can't go with the password-based authentication. You need a token, access token. Got it? So we need to create access token. We have to create access token, and with this access token only we can able to log into your Docker Hub account through CLI or API. So I'll just show you how to create access token here. So just log into Docker Hub account first. And once you log in, right, on top right corner, you can see your account name. Click on this and go to the account settings. Go to the account settings. And from account settings, you enable something called security. Click on security tab. It will take you to some security related activities like creating access tokens or creating a multi-factor authentication, right? So in this case, you can able to create a access token. Just click on new access token. I repeat, from your account settings, click on security tab, and here click on new access token and give a token name. Just give a name of the token and access permission. Using this token, what are the activities you can able to perform? Whether you want to read the image, write the image, or delete the image, or as per your need, you can able to specify the access permissions and click on generate. So this will generate a token. Okay, this is what we need to log into your account. And even it is giving a recommendation like we have to copy this token. Why? Because it is generated once and you can't retrieve it back. So if you want to preserve it, you can simply copy and keep it in a separate file system. And if you want to log into Docker Hub, this is a command through CLI. So it is giving a recommendation, Docker login -u followed by the login ID. And it will ask for the password. Just copy paste the password. That's it. Any question? That's it. So then after, if you want to access a token, you can't get it back. So you have to create a new token out of it. So now let's see how to log into this Docker Hub now. So my intention is I want to publish the image. What are the images I've created here? Docker images, right? So what are all the images I've created here? I just want to publish to Docker Hub. So while publishing Docker Hub, where it will get published, that matters. So last day itself, I talked about the Docker registry and Docker repository. So let's say in this case, from your Docker account, you can able to see something called repositories. So repositories are nothing but a subset of your registry. So as per the need, as per the application need, we can able to create a number of repositories. So when you create an account, for the very first time when you create an account, the account will be created, the repository will be created based upon account ID. Loksai ETA is my account ID. On the same account name, it will create one repository. And whenever you create any image, while creating image itself, you should use a account name as a prefix, or sorry, repository name as a prefix. If your intention is to publish to Docker Hub registry means, just create an image with the help of your repository name. And it is also best practice, okay, so that you can able to directly map to that particular repository. Or if you want to create new repository, you can create a new repository here. Click on create repository, give a name of repository along with description, and you want to make it public or private, and create it. So now that I have a repository called Loksai ETA, within this repository, I want to publish one image. So this was the last image I published 6 days ago. So now let me run this command. First, I need to log in. So from your console, that is from your CLI, just issue a command, docker login command. Now it is prompting for the password. Just enter the password whatever generated, the access token. Enter. Just right click, okay, it just copies that. That's it. Now login is successful. Once the login is successful, what you can do, you can able to issue Docker push command. Docker push. It is something like publishing the image to the Docker Hub registry. Okay, it's very simple. Followed by the image name. So now in our case, I want to issue Docker push followed by the image. This is what the image I want to use. So whenever you create an image with a tag, you have to give a tag name. Without tag, if you pass the image means it will expect for tag, it will fail the push activity. But if you haven't created any tag means you can simply say the image name. By default, takes the latest as a tag. See, it is trying to push the repository. See, almost 160, 126 MB. It's done. So now that if you go to your repository, Docker registry and check your repository list, you can able to see the latest image, whatever we pushed, it is available here. And it is a public repository. Okay, so anyone who wish to access, you can able to access it. Like if you click on this image name, you can able to see these are the properties of the image. This is a tag which I have created, and it's having this layer. So on top of the batch CMD, we have created two layers. That is, we update the package and we install Git. Remember, that's what we did know in the Docker file.
Yeah.
So let's create a new layer out of it, and now this image is composed of a Git also. This is my private view. As a owner, I can able to see this page. But how this image is represented for the public means, if you click on the public view, it will be available like this. So when you try to search for this image, you can able to see image in this manner. And you can able to pull the image and make use of it in your local machine. Easy. Are you able to understand these things?
Sai, if we have new repository with the same account, right? Your account, your user ID is logsci.ita, and now this is the repository. Now what we do, repository, it will store in this default repository. If we create the new one with the same account and push this image from CLI command, will it go there or?
See, you are giving a login, right?
Yes.
And you're getting credentials, right?
Yes.
Specific to your account.
Yeah, that's right. But what if we have more than two repositories? One repository
More than one repository in the same account, or
in the same account.
then repository name should be unique, no?
Namespace. Can you go back to Docker Hub? Okay, here under repository, and click on create. Yeah, that one.
This is the only
Namespace.
repository I have. Correct. So if you want to have more than one repository, just click on create.
Okay.
And give a name of a repository which you want to create. And you can able to maintain your images or make it public or private as per your choice. Got it?
Yes.
Any question, please let me know. Are we good with this, all of you?
Yes.
Okay. So that's all. These are the major activities when we work on Docker. Okay, like Docker means it is meant for managing your application images and how the application's images are created, how it is published to Docker Hub. This is what the primary activity. So apart from that, on application level, if they are working on microservice architecture, If you want to run multiple containers at the same time, we'll be using some Docker Compose. Okay. Anyways, we are going to discuss about the same thing in Kubernetes. So if you see here, we have something called Docker Compose. So the purpose of Docker Compose is used to run multiple containers as a service. Okay. It is used to run multiple containers as a service. Yes, need to create account. That matters.
Okay. So I tried, but uh, okay. I need to create this account, right? Okay.
It is hub.docker.com, not hubdocker.com.
Okay. Hub dot dot com. Okay. I will create. And then this all information I can वहाँ पे देख I can see there, right?
Yeah, you can access.
Okay. Yes. Okay. Thank you.
All right. So yeah, Docker Compose means it is used to run multiple containers as a service. So for example, whenever we talk about microservice architecture, you can consider the same example what we have seen here. So my web application is composed of various services, right? So each and every service has different layers, like it can be front end, application logic, or back end. And all these three layers are responsible to run the service. So if the application team deploys all these things in the form of containers, they can't run all these containers separately. Like even the startup also. If I want to run the container, Docker run -it followed by C1. So, and then I need to run another container C2, C3. Like that, each and every container has to be executed independently if you're going with a simple Docker approach. So further we use something called Docker Compose. So using Docker Compose, we can able to run multiple containers at the same time. And you can able to start all the containers or stop all the containers at the same time. Everything is possible. For that, you have to install Docker Compose. Docker Compose is not the base property of Docker. It won't comes by default. It is the external component we have to install on top of a Docker engine. Then only can able to work on those things. And the installation is very simple. Just say like Docker apt install docker -compose.io. It will install the Docker Compose. And we can able to run all the containers by creating some services out of it. So in order to do this, we'll be using some manifest file. So the manifest file is used to define containers. So how many containers you want to run, it will be defined in this manifest file. And using that CLI commands, Docker Compose CLI commands, we can able to execute the manifest file. So it is something like writing a script. So far what we did, we just running some ad hoc commands, Docker CLI ad hoc commands, we're running it. Ad hoc commands means only one command can be executed at a time. But if you want to run some series of commands, what we can do, we can put it in a script and the script can be executed, right? So same concept is here actually. What are the commands you want to execute to run the containers? Just define all these things in the form of manifest file. And when you run that particular file, it will run all the container as a single service. Easy. So that is how we just manage our Docker Compose. So while you're running this Docker Compose, all these three containers are responsible for my application. Even if one application or one container is down, it will impact the entire service. So how to orchestrate all this things by using a Docker Swarm. I think I already talked about this, right? Here it is. A container orchestration tool. You can refer the same. So ultimately, using Docker Compose, we can able to orchestrate the containers. We can combine all the containers, what are things required for the service. And at any point of time, even if one container is down, it will automatically create some replicas and ensure that the new container is up and running. So how to ensure high availability means, let's say I have a container which is up and running. So as per my analysis, this container is sufficient to serve my application. But all of a sudden, if the traffic is very heavy, what will happen? Yes.
The
We,
request would be, I mean, we can use the load balancer in that case.
so whenever the traffic is more compared to the expected list, in the case, the application cannot respond to all the users. The application might go into exit state, or sometimes user will be getting 404 error, page not found error, right? So all these things will be issues will be created runtime. So to overcome this, what I can do means I am not going to rely on one container for my deployment. I'll be creating replicas of containers. Containers. So these replicas of containers will help to support my application. I can able to run all sort of applications using this replicas itself. So once we have this in place, then let's say I have created 3 replicas. Means to run my application, we have 3 replicas of containers. Even if one copy of my container is down, I have another copy to support, right? So that's why without any downtime, if you want to achieve your application deployments and containerized applications, we can able to use Docker Swarm. So Docker Swarm is one of the orchestration tool that is meant only for Docker images. And it is not recommended for managing the heavy workload or huge list of microservices, because the properties like load balancer, auto scaling cannot be effectively done with the help of Docker Swarm. So for the purpose only, we use something called Kubernetes. So Kubernetes is also considered as the orchestration tool, which ensures high availability of your containers and the applications, which creates a number of replicas. It allows you to implement a load balancer and as well as the auto scaling. Because if you see here, in this case, I said 3 replicas. What if 3 is not sufficient? We have to scale up, right? Are you getting a point? We have to scale up. And if the server is not in use or if the traffic is very less, then again, we need to scale down. So all these things can be effectively done with the help of Kubernetes. So what are things we're talking about here, like a manifest file creation for Compose and the Docker Swarm, all these things, I'll show you how to implement in your Kubernetes. That will be more relevant. And while working on Kubernetes, I can able to compare how Kubernetes is superior when compared to Docker Swarm and Compose. So it'll be easy for you to relate the things. Are we good with this? Any question? So ultimately, Kubernetes is a open source container orchestration tool. Okay. So this is what the property. It is used to ensure high availability of a container. And it's open source. Okay, that is one important point. And it is basically a Kubernetes master and nodes architecture. So in order to work in Kubernetes, first we need to understand the Kubernetes architecture. Okay. So what is this architecture is all about? What are the various components of architecture we have? And how the components of this architecture interact with each other? What are the dependencies we have? Everything. And then we have to set up the Kubernetes master and worker nodes. Got it. So these are things we need to focus on, and we have something called Kubernetes controller objects and replicas. All those things we'll see one by one. Don't worry. So shall we talk about the architecture now? Guys,
Yes.
you want to have some break? You want, just let me know. We can plan it accordingly because it requires considerable amount of time. Architecture setting up means like installation. And this Kubernetes, I said it is open source, right? It is open source means even we have something from managed service also. I think we already talked about it. I remember somewhere. Yeah, it's here something. Right. So these are the managed services. Whenever we're talking about container service, from Elastic Container Service or Elastic Container Registry and EKS, Elastic Container Kubernetes Service, is provided by AWS. And for Azure, we have Azure Kubernetes Service. So if you get into your interface here, I have both for Azure and AWS here. So in AWS itself, you can able to export the service. So Elastic Kubernetes Service. So the main difference is your Elastic Kubernetes Service, it is a managed service and it does not comes with the default free to micro instance or a free tier account. It is not eligible for free tier account. So you need to pay some extra dollars for each and every hour you work. Got it? And but here the creation, installation, and configuration is very, very easy. You no need to spend more time. It's something like a form filling activity. If you want to create a Kubernetes cluster, you can simply fill all the required parameters from all this tab. And within a few seconds, your entire Kubernetes cluster as per your configuration will be up and running. But when it comes to open source Kubernetes, the initial configuration consumes a lot of time. It's like, we have to pay more attention while configuring the Kubernetes, open source Kubernetes. It involves a lot of dependencies and a lot of, steps to follow. Even if you miss any one of the parameters, it might impact and you have to recreate. A lot of complexity will be there. But once it is configured, then after you can able to run without any issue. It is that much powerful. It's something like install once and forget about it. Like that, it will work. That much it is reliable. All right. So you just have a break and come back. We will talk about the Kubernetes architecture and installation today. So this itself will take at least for another 1.5 hours, 2 hours. So better you have a break and come back. And this week you can focus on the installation configuration.
Okay.
Because if you do it on next week, right, there'll be only 1 day gap difference. So in that 1 day, definitely you can't achieve much. So what you can do means today we'll focus on installation of Kubernetes, so that we'll be having 1 week time to analyze and assess the things. If you have any doubts, you can able to talk about it on next session. All right.
Okay.
Okay.
All right, guys. Just go have a break and come back. How much time you need? Yeah, I'll be sharing the installation documents with you. Okay, I have a detailed document for Kubernetes. We'll share it. Yes. 15 minutes will be sufficient or what?
Yes, as usual, 15 minutes.
Hello? All right, guys. Carry on, please. shall we? Hello? Yes, I'm audible to all. Shall we continue now? Hello, hope all are there. Or...
Yes.
Okay, thanks. All right. So now let's talk about the Kubernetes architecture, which is considered as one of the important topics for any DevOps implementation, especially when it comes to the deployment of microservice-based applications. So let me show you that architecture diagram now. 1 minute. Okay. So as we have seen, right, Kubernetes is one of the master node architecture. So where we have to maintain all the.
Sir, your voice is very low.
Okay. Is it better now?
Yes, better. Yeah.
All right. So we'll be talking about the Kubernetes architecture. So let me pull that workflow diagram for you. So this is what a basic architecture diagram for Kubernetes. So if you look into this workflow diagram, listen please, all of you. So it all starts from the developer. Okay. Because developer is responsible for the application development. Once the application is ready, they will perform the automate build, create the artifacts. And once the artifact is created, they'll be testing the artifacts first of all for all sort of unit testing, everything. Once the testing is completed, they will create an image out of it, a Docker image out of it. Using Docker file, they will create an image. And once the Docker file, image is created, that image will be published to the Docker Hub registry, right? So that is what we did so far. So in our case also, using Docker build command and Docker commit command, we have created some images and we have seen how to publish that image to Docker Hub, right? So now the image is available in Docker Hub, application image is available in Docker Hub. So once it is available there, how you can able to deploy it in the target environment? The target environment can be anything. It can be the testing environment like QA, UAT, or even the production environment. So from the Docker Hub, if you want to automatically deploy those components in the target environment, and not just about deployment, okay, it is all about ensuring high availability of the deployed object. So that can be effectively done with the help of Kubernetes. So basically Kubernetes is the master and node architecture. You can have one Kubernetes master and you can have a number of worker nodes. So what is the need for Kubernetes master means? It is used to actually process the request. What are the requests you want to create or you are going to process? Everything will be validated, it will be processed by master and schedules that application deployment to the corresponding worker nodes. So these worker nodes are responsible for the actual deployment. Correct. The applications are deployed in the worker nodes only, not like your master node. So now how it works, what are the various processes involved means. So as a developer, once the image is ready, once you publish the image to Docker Hub, he'll be creating a configuration file, a manifest file. Remember, I talked about the manifest file, right? It's going to have the definition of all the containers, what are you going to run. So this manifest file can be written in YAML scripts or it can be in the form of JSON file format. So usually we use YAML scripts to write the manifest file. So this manifest file will contain the complete information about the containers, what are things you want to execute. Like for example, to run a container, what I need? I need a container name, and I need the image which is responsible to run the container, right? And if there is any port mapping, I need to specify the port numbers. And if the container is having any volumes, I need to define the volumes there, right? Like this, what are the properties that is required to run the container or deploy the container? Everything will be defined in this manifest file. And this manifest file will be submitted to the Kubernetes master using a CLI called kubectl. So kubectl is a command line utility. Command line utility. It's something like a Docker. Docker also is a CLI, right? So through which you can interact with Docker engine. Similarly, if you want to interact with Kubernetes, you'll be using kubectl. So using this kubectl, we can able to submit our request. The request can be in the form of manifest file or it can be ad hoc request also. It's possible. So once you submit the request, it will reach us the Kubernetes master node. That means actually we're interacting with Kubernetes master here using kubectl. And now this API server is one of the very first component that is present in your Kubernetes master. This API server will receive the incoming request. This acts as an interface between the user request and the Kubernetes. It will receive the incoming request and it will validate the request. Like what are the manifest file we have created, whether it is valid or not. What are the containers or images or even the definitions. And not only that, the developer or the user who submits the request, whether it's the authorized person to submit or not. So it check for all the user level access, the feasibility and the resource definitions, everything. And once the request is valid, it updates the request in the etcd directory. etcd directory, or it is called as etcd database. So this etcd acts as a complete source of information. Whenever we talk about Kubernetes, the entire Kubernetes related information or data will be maintained in this etcd database. It is a complete source of data. Like tomorrow, if you want to query something from Kubernetes master, or if you want to know something about the worker nodes, so all the information about Kubernetes master, its worker nodes, and the applications which is running in the worker node, everything will be captured with the help of this database. So now once the API server updates the request in the etc database, it will just send a notification to scheduler. Scheduler will identify the request and it will try to identify the healthy worker node in the target. Correct. Because let's say, for example, consider I want to deploy one container application and that application needs around 5 GB of volume. That is one of my requirements. So out of these 3 nodes, which node is capable to run that much volume? That is what the healthy state of that node, right? So it depends upon the actual requirement. It will verify the node details and identify the healthy status of the node. Got it? Once it identifies the healthy state of node, it updates the node name against that deployment object. And now we got the healthy node details available in this directory. API server will pick up the details and reaches the corresponding node. And in each and every node, worker node will be having a kubelet. So kubelet is considered as an agent that is running in all the nodes. So this API server will connect to the corresponding worker node and it shares the details with the kubelet. Now the kubelet what it will do means it will verify the request and it just shares the request to the container runtime interface, CRI. So what does need for this CRI means? CRI is responsible to identify the image from Docker Hub and it just pulls the image here. Got it? Which image you want to pull it from Docker Hub? It will be pulled from the pulled using CRI. So once the image is successfully downloaded, the kubelet is responsible to deploy that image in that worker node. Got it? So this is what the basic workflow when it comes to your Kubernetes architecture. And apart from this, if you notice, there is a component called kubeproxy. The kubeproxy is responsible for the networking. Like tomorrow, you might be deploying a number of containers and pods. So if you want to establish communication between the pods and between the containers or between the nodes, the entire networking will be taken care by this kubeproxy. And I'll show you how the networking is established and all. I'll talk about it in some time. And apart from all these things, we have something called controller manager in the Kubernetes master. So this controller manager is responsible to ensure that the request, whatever submitted by the user, it is working or it is running as expected. Let's say, for example, consider this developer has requested to run the container with 3 replicas. 3 replicas means at any point of time, it should have 3 replicas up and running. Due to some reason, if even one copy of the image is down or container is down, it will immediately create a new version of it. So in order to ensure the desired state of your deployment, your control object will be continuously monitor the execution. And if anything goes wrong, within few seconds, just bring it up to the previous or successful state. So I'll show you that also, how it works and what are the components we are going to use here. So this is about the architecture of Kubernetes on high level. So all that you should understand here is what are the components we have in the Kubernetes master and what are components we'll be having in the worker node. So API server, it acts as a front face, which is going to receive the incoming request and updates the request in etcd. etcd is just like a database that contains the complete information about Kubernetes and its deployments. And scheduler is responsible to identify the healthy node, and it is used for scheduling the applications or containers. And then we have something called controller manager. Controller manager is used to keep your pods and containers up and running as per the desired state. And on the other hand, if you're talking about worker node, means we have kubelet. This acts as an agent. It is running in all nodes. And the CRI is responsible to pull the image from the Docker Hub and deploy it. And finally, we have kube proxy that is responsible for networking. Easy? Any question here? Any questions from anyone?
Can you recall that? I mean, how we can, let's say API server gets the request and etcd as a database will store the state of the container, right?
Not just state of a container, it holds the complete information about the Kubernetes, like what is the name of the master node, worker nodes, how many nodes are available, what is the status of each and every node, whether it's up and running or not, and how many pods and objects you deployed already, what is the status of it. So etcd acts as a data source for Kubernetes.
Okay. And once this request is updated in database, so how, there is no back arrow. API server would communicate directly through to the kubelet, right? For that.
Yes, see, your API server is responsible for the continuous interaction with the etcd. Got it?
Yeah. Yeah.
And no component can able to interact with each other. Like for example, if scheduler wants to interact with etcd, means it can't directly interact with etcd. It should be done through API server only.
Okay.
Similarly, if controller manager wants to pull anything from etcd, it should be done through API server. So API server acts as an intermediate component between all the Kubernetes objects and the components here. Even if agent, as a agent kubelet, right? If it requests any data, that will be processed from API server only. It matters.
And here kubelet would just see, like, manage the containers, right? It would manage the containers.
It is responsible for the deployment.
And how would this control manager would take care of, like, whether the state of the deployment
That is
handled?
what the object. We have various control objects available. We have something called deployment controller object. When you create a deployment controller object, that is going to create some copies of pods, replicas, and ensure the upgrade and rollback. And also, it is continuously monitors the execution of your pod. Whenever we deploy anything, what is the current state, whether it's up and running or not, everything.
Okay. All right. Thank you.
So here we have something to understand about the terminologies. Okay. as like Docker terminologies, we have something called Kubernetes terminologies. So already we were using something like images, and we know about containers, right? And there is something called pod, and we'll be having something called deployment. Controllers, and we have something called services, and also we have something called networking. Okay, and what is it called, namespaces, right? So all these things are some terminology. So whenever we talk about Kubernetes, we never use a term called container. Got it? For deployment purpose, we can refer the container internally, because in Kubernetes we never directly deploy the container. The containers are deployed in the form of pods. So pods are nothing but a smallest, or we can simply select atomic unit of task, what you're going to perform on the Kubernetes. Atomic unit of a task or schedule. So whenever you want to deploy any container, that container will be wrapped in the form of pods, and the pods are getting deployed. So it means a pod can have one or more containers. That matters. So if you look into this architecture diagram here, which I was showing you, in this architecture diagram also, as part of the deployment, what we're going to do here is the container runtime will identify the container image from Docker Hub. Once it is successfully downloaded, your kubelet will deploy that image in the form of pods. These circles, whatever you can see here, you can consider as a pod actually. And the square brackets, I mean, what is it called? Blocks, blue color blocks, what you can see here. This you can able to consider as a container. So we can't directly deploy the container. The containers will be deployed in the form of pods. So pods are nothing but the smallest unit of task that you can run in the Kubernetes. And a pod can have single container or multiple container. And as a best practice, whenever we talk about the deployments, it is always recommended to have a pod with one container. If you have more than one container pod, it might lead to some complexities, and the underlying architecture should be able to handle it. So as a best practice, we'll be managing a pod with one container. And whenever we create any pod, whenever we deploy any pod, each and every pod will be having its own IP address. That's very important. And a container which is running inside the pod will be having its own port number. So that is how the container can able to communicate. Let's say I have two pods here. If I want to communicate between these two pods, I'll be using IP address of the pod. Similarly, if I want to communicate between these two containers inside the pod, I'll be using the local host followed by the port number of the containers. So that is how the networking will be established. The kube proxy is responsible for that. Right. So I'll show you a demo of all these things. Okay, how to deploy a pod, how the container is getting executed, how to assign the port number for each and every container. That we'll see in the upcoming sessions. So as of now, keep in mind, your pods are nothing but the smallest unit of task. And once a pod is created, automatically your pod IP will be assigned to a pod. That is uniquely assigned, and it is internal. We can't use that IP address to access a pod through internet and all. It is just for internal cluster level. The deployment control object, services, networking. I'll talk about it while we handle that session. So now the important thing is the installation and setup of the Kubernetes. So basically this Kubernetes, whatever we're talking about, right? It composed of Kubernetes master, and it can have Kubernetes worker nodes. Like this. Right. So there is one more term called cluster. Cluster is nothing but collection of worker nodes. Collection of worker nodes is called as a cluster. So let's say I have 3 worker nodes, means these 3 worker nodes can be considered as a cluster of nodes. Like that we can able to consider it. So in general, how it is categorized means I'll be having Kubernetes master, which will be having the cluster. So this is cluster 1 we can have. Cluster 1 can have its own worker nodes. Similarly, in a real-time environment, depends upon the topology, we'll be having more than one cluster also for this worker node, master node. It's possible. It means we're just trying to grouping up of worker nodes in the logical name called cluster. Cluster is a logical entity. It is just a logical name that we assign to identify the group of nodes. Right. Like that, some complex environments will be having a backup for master also. So why we need these many worker nodes? Any idea? Let's say I have a master which is responsible to identify the requirement and schedule it. Once it is scheduled, it is going to get deployed in the worker node. Why can't I deploy in one worker node? Why should I have 3 different worker nodes, more than one worker node there?
For high availability of application.
To handle the lot of requests.
Yes. So this is what we call it as ensuring high availability. It is not about the containers, okay? It's not about the application. When I deploy my application in one particular node is just a VM, right? So when I deploy this in one node, that node should be available first of all. Due to some reason, if node is down, or due to some CPU utilization or memory utilization, if I'm unable to reach that node, I'll be losing my application. So even if your node is down, you should not lose your application. That's the main agenda here. So whenever we talk about the replicas, let's say I have a container, my Tomcat application container. Container, it is deployed in the form of pods, right? Pods is the smallest unit of task I told you. So whenever you try to run any container, the container will be running inside the pod. So when I deploy a pod, I'll be creating replicas of it. Pod. Replica means, let's say I can say replica has a 3, or if I say 6 as a replica means, how many worker nodes we have? We have 3 worker nodes. So each node can run 2 copies of pod. 2 copies of same pod will be executed in all the available nodes. Like this, it will be scheduled. This is just to ensure high availability of application. Even if one node is down, you have another 2 nodes to support the application. Even if one copy of the pod is down, you have another copy to support the application. Got it? So availability means it should be maintained based upon the application level, I mean the pod level as well as at the node level. That's the reason we have these many replicas of nodes and pods. Understood? But don't worry, all these things we are not going to do it manually. That is the reason we use Kubernetes. It will identify the healthy node and it will try to equally distribute the workload in all the nodes. Got it? And at any point of time, if one of the pod is down, it will automatically create a new pod based upon the configuration. So all this demo I'll show you in the upcoming slides. So let me get into this installation first. I'll show you how to install this today. Once installation is completed, we'll gradually work on all the components like deployment controllers, services, and all. Okay, so things are clear, right? Or any confusions here? Are you guys able to understand the flow?
Yes. Just one query for this cluster. Let's say if we have 2 clusters, so those IP I mean, IP would be assigned to the cluster or to
No,
the
at the
pod.
pod level, only to the pods.
Okay.
Clusters are just a logical entity.
Okay.
Cluster is just a logical entity. Okay. So let me log into my console. Okay, guys, this initial architecture and the installation, definitely it's a time consuming process because we have to take care of the master node and all the available worker nodes. And there are some prerequisites also, like in real-time environment. Whenever we talk about real-time scenario, we'll be having setting up the same level. Okay, like installation and configuration can be done based upon various scenarios. Like we use something called kubeadm utility, or we can able to use minikube. Like for example, if you're talking about the production workload, these things are very much complex workload, right? So in order to achieve all these things, right, we'll be using kubeadm utility to install and configure Kubernetes. But if you're using minikube, means minikube is considered a lightweight version of the Kubernetes. Just with a single node, you can able to demonstrate all these things. So if your intention is just to learn about Kubernetes, you can able to use minikube. With a single node, you can able to demonstrate everything. But if you want to experience the production level of implementation, it is always recommended to learn something based upon your kubeadm. And this kubeadm involves a lot of steps and a lot of repeated steps. So we have to take care of each and everything one after the other. And another important thing is, whenever we talk about kubeadm installation, right, it has its own prerequisites, I told you. So the hardware requirement, that is your VM, whatever VM you use, at least you should have a 3 GB RAM. At least you should have 3 GB RAM, and it should have at least 2 plus CPUs. That is a basic requirement. It should have at least 3 GB RAM, or at least 2 plus more than 2 CPUs are required. It means in our case, we are just using T2 micro instance, right? In our AWS platform, we use T2 micro instance, no free tier account. So with this T2 micro instance, we can't get around a 2 GB or 3 GB RAM and all. It provides only 1 GB RAM and 1 CPU. So for the sake of demo, we can use it, but in real-time environment, we never encourage this configuration. So at least we'll be going with the T2 medium or T2 large, which provides 4 GB RAM and 2 or 3 CPUs. So I'll show you, once we start with T2 micro, definitely throw some error. So I'll show you how to handle that issue. Got it? So this is about the requirement for Kubernetes. And if you are interested to go with T2 medium or T2, that is not an issue. You can able to go ahead, but it is not required at this point. I'll tell you when it can be utilized. Yeah, so I'll show you a reference material, okay, from where you can able to download Kubernetes and all. It's a very interesting document. So this is the official documentation, okay, for Kubernetes. If you want, I can put it in the chat window for reference. Listen, please. So from this, it's a very good document, yeah, really. It's a really worthy document, okay. It's all detailed documented and it is having some use cases, scenarios, test cases, a lot of things are there. If you want to specialize on Kubernetes or if you want to do some sort of certifications, you'll get a lot of information from here itself. But it is not that easy to understand during initial days because few things are not straightforward. Okay, we have to go through a lot of things, a lot of dependencies. A lot of links will be there. Like if they're talking about something, they never talk about it here directly. They'll give you some link and that link will take you to another link. Like there's some chain of actions. There are a lot of documents already created. They just try to combine everything in a single site. That will deviate the flow. So that matters. So if you want, you can get into this production environment and you can able to explore these options, like how to install Kubernetes. Like we have something called KubeADM, bootstrapping cluster with KubeADM. So these are steps involved. So these are various steps involved in installing Kubernetes. And here as well, they're given the clear requirement for your installation. What is the hardware requirement and what are the dependencies we have, everything. So we have to install KubeADM, kubectl, and kubelet. All these things are Kubernetes components. So ultimately, to install all these components, we have a lot of dependencies. Like we have to take care of the dependencies also, starting from this level. And depends upon each and every machine type, whether it is Ubuntu machine or Red Hat. Depends upon the machine, we have to take care of all the dependencies. If you want, I'll give you a quick summary, overview of this. Okay, what are things needed to install Kubernetes means the very first thing is the nodes. Node means you should have a master node and the worker node. I'm going to configure this thing now for you. So we have to create a VM. I'm going to create 3 VM now. And out of that, I'm going to make one as a master and two as a worker nodes. And once the nodes are ready, you have to properly tag the node name. That is very important. So that it will be easy for us to recognize the node. Tomorrow, if you deploy any pod, in which node the pods are getting deployed. To understand that, we need to properly tag the node. And then we have to install Docker and ensure the Docker service is up and running. And similarly, we have to install container runtime interface. Here we are going to use container D. Container D is one of the container runtime interface we need to install in all the nodes. And then to install this container itself, there are a lot of dependencies. Okay, we have to download a lot of repositories, the IO keys, and we have to update some config files. A lot of dependencies will be there for container D. Once container D is installed, you have to ensure that the container D is up and running. Once it is up and running, then only you can able to install your kubelet, kubeadm, and your kubectl, all this stuff. And then also the port also very important. The ports to be exposed. Because each and every component of Kubernetes, like what are things we talked about, right? Like API server, controller manager, scheduler, etcd, kubeproxy, kubelet, kubectl, all these things will run in its own port number. So we have to properly enable all the required ports. And what are the nodes you are going to use? It should have a complete network connectivity. There should be a full access to all the nodes. That means there should not be any firewall restriction. If you have 100 nodes, means all the nodes should be accessible. There shouldn't be any firewall restrictions. So even it is all mentioned in this document itself. In this, from here only, I just talking about like all these things. A full network connectivity between all the machines in the cluster. There shouldn't be any firewall restrictions. So to disable the firewall, to disable the swap, we execute a lot of commands here. Right. So maybe first time it looks very hard to digest, but it's not that big deal. Once you start using it, that's the reason I wanted to cover this today. You'll be getting some enough time to practice this. So based upon this document, right, official documentation, I just created one summary of commands and a list of commands. I'll be sharing it with you now. People can follow the same document. One minute, let me open the document for you. Okay. So this is the one. Okay, listen please. Okay. So if you can see my page here, starting from the very first level, so you can simply follow this. Okay, it is something a production equivalent. Even real-time environment also will be having such manuals, okay, for managing the things and nodes, because we never do all these things manually. What we do is, what are the commands we need? We just put everything in the form of scripts, and scripts will get executed using Ansible or any other approach. So I'm going to launch 3 instances now, and once I launch instance, as we know, we have to enable all the network related things. There are nearly 6 to 7 port numbers has to be enabled for all the services. And apart from that, if you're talking about node port, means it is having a huge list of port numbers. So for that demo purpose, I'm going to open all the ports, all the available ports. I'm just opening for you just to demonstrate. But in real-time environment, what are the ports you need to use? I'll be giving a list of ports. And there are certain commands, certain tools has to be installed in all the nodes. That is in master as well as the worker nodes. If you have 10 worker nodes, means you have to install all these things in all the 10 nodes. That's very important. So what are things you're going to install in master and worker node means? First, as I said, we are going to tag the node. You have to assign some node name, right? So that's what we're going to do here. Set the appropriate host name for each machine using this command, sudo hostname ctl command. And once you assign the name, then you'll be installing Docker. And once the Docker is installed, we have to install the container runtime interface, CRI. So CRI here, we're going to use this container D. So the actual container D installation is at this level. Here only we're going to install this container D command. But to install this container D, we have some prerequisites. That's what we're doing here. We have to load the required modules. We have to update the IP6 tables. And then we have to install a curl command to download some container D repositories and the IO keys. Once the repository and IO keys are downloaded, then we can install container D in that machine. And once the container D is installed, we have to do some post-installation activity for container D. We have to update the config file and ensure that the container D runs in its own namespace by using some control group. So we have to update the file here. Once it is done, we should ensure that the container D is up and running. We have to restart the container D. And then we'll be installing the Kubernetes components like your kubelet, kubeadm, kubectl and all. So to install these components also, we have to download some repositories. And finally, we have to enable the port numbers. If you are not opened your allow all traffic means, then you can able to explicitly give this command to disable the firewall and all those stuff. So we have some port numbers like 6443, 2379, 2380, all those stuff. So these are ports has to be enabled for all the nodes. And then we have to disable the swap, because this swap is something used by the kubelet. So kubelet, right, what is going to mean is going to deploy a pod. And at any point of time, if the pod is down, it automatically deploy a new pod, and it should resume the task from in the new pod. It won't start from the scratch. So for that kubelet to work properly, we have to disable this. We have to give swap of A, and then we'll be restarting or enabling the kubelet. So all these commands should be executed in all the nodes. All the nodes we have to execute. And once it is done, there are few commands that should be executed only on master node. Like we have something called kubeadm command. This should be executed only on master node. And once you execute this command, we can see that the kube master will be enabled and is initialized. And once it is done, then we need to do some follow-up command based upon the instruction given. And once the kubeadm is successfully initialized, the master, then we have to use the kubeadm join command to join your worker nodes to the master node. So this is how we just enable the configuration. Okay, it might be boring, but still no other option. So shall we proceed now, guys?
Yes, Sanjay.
Okay, any questions before we proceed, or okay, I'll be launching some servers now. So we can use Ubuntu machine. And use the previous version of Ubuntu 20.04. And let it be T2 micro itself. Just for sake of demo, T2 micro is more than sufficient, which comes with 1 CPU and 1 GB RAM. But in real-time environment, this is not sufficient. Okay, you'll be using either T2 medium or T2 large. Okay, with 2 CPUs and 4 GB RAM or 8 GB RAM. But if you use it now, it leads to some billing, because your free tier account is not eligible for T2 medium or large, right? So just go with T2 micro. I'll show you how to handle that issue. Now, key pair, you can choose existing key pair for all the nodes. And we're going to launch 3 VMs here. All right. So Ubuntu, previous version, T2 micro, key pair, and the number of instances. So with these parameters, just click on launch. Okay. Right. So let me rename this. SA DR Kubernetes master. And I can name it as node 1. This is just a tag we are sending, okay? Node 2. So now once the nodes are created, the next step is to enable the port numbers. So if in a real-time environment, we'll be getting into the security group and enable only the required ports. Like I was talking about the list of ports, right? Only these ports will be enabled at the initial stage. Gradually, whenever required, we can add more ports. That too purely depends upon the company's security policies. But for the sake of demo, you can able to update all the port numbers because I don't want to go and update each and everything one after the other. So just go to your security group of this node, click on security group, and here under security group, you can able to edit inbound rule and add the rule. And CAD block it will be zeros. You can either use a port number or with a range, or you can simply say allow all traffic. Both are same. There is no difference. Got it? So you can either give all traffic, or if you remember the range, you can able to give the range also. That's not an issue. So save these rules. So since we have launched all these three instances at the same time, the security group is common for all the servers. So no need to assign it for each and every level. This security group is common for all these three servers. So now let's get into these machines. Each and every machine we can log in and do the installation. And let's get into worker node 2. Right. So what is this? This is a Docker slave machine, I believe it. All right. So sudo -i. First, let's update the packages. Okay. So once I launch the machine, sorry. So once the machine is launched, I just update the packages. That's all I did here. And now, once the package updates are done, we need to change the host name, because whenever I refer the node will be referred with the help of the IP address, right? Each and every node are getting referred with the help of IP address. So tomorrow when I deploy any pod, I'm not going to schedule the pod in any specific node. It is done by the scheduler. So just by looking at the IP address, I can't figure out in which node is running. So if I assign some tag, it will be easy for me to recognize the node. So for that purpose, we have to change the node name or host name. So to change the host name, this is a very syntax actually, like a sudo. We have to update that host name CTL. That's all. First, go to Kubernetes master and run this command. Host name CTL, sudo name is kubemaster node1 or node. And in order to make it effective, just run the command exec bash. See here, instead of IP address, now it is turned to master node, whatever we assigned. But this is just a temporary change. When you reboot your machine or restart your machine, again, it'll go back to your IP address. Till the session is available, it will be accessible like this. So if you want to permanently make these changes, you have to update this host name in this file, host file. Just edit the host file, go to insert mode, and here you need to specify the IP address of the machine along with the node name. So you just go to your node first, and this is the master, right? Just take the private IP address of the node and have it here. So this private IP address should be assigned with the node name. Clear? Save this. That's it. So now that we have updated this file, and then after, whenever you try to access or log in, it will just opens with the kmaster node as a reference. If you want to quickly reboot and verify that once. Let me reboot this machine. Sorry, it should be done here. It is getting restarted now. So in the meantime, we'll fix the name for node 1 and 2 as well. So similarly, if you want to update the node name for worker nodes, just execute the same command. Worker node 1 and exec bash to verify that. And similarly, you can update the file sudo etc host file, go to insert mode and add the IP address of the machine. So take the worker node's private IP address and update it here. So this is what this is the way we'll be updating it, okay? So either you can directly update in the file or you can use your setup command. And in this node 2 also we need the IP address. So in real-time environment, we never do this manually. We just handle it through script itself. Like all these things are shell commands, okay? If you want, you can able to run everything as a script directly. On my worker node 2. That's it. So now upon restart, see, after reboot, I can see the values are same. It has not changed. All right. So now that our machines are ready with the host name, all three machines are ready with the host name. Take some time to reboot, right? Last machine. Fine. So now we'll install Docker in all the nodes. For installation is same as how you did in your previous module, apt install docker.io. As a root user, we need to do this activity. And similarly, in node 1 also, we have to install Docker. And node 3. Following, right? Hmm? Enjoying Sunday with Kubernetes. All right. So now that we have installed Docker in these two nodes, let me install it in work node 2 as well. All right. So now we'll go step by step. Okay. I don't want to dump all these things because it might lead to some confusion. So first, we'll try to focus on all these commands with respect to containerd. Once it is successfully installed, then we'll go on to next node. So first step to install containerd is to load all the dependencies. So simply copy these commands. All the lines which are executable are available here. These lines are committed lines. Okay, you can simply ignore it. So just copy this command. Let me focus on worker node 1 now. That's it. And then these commands to update the IP6 table. See, all these commands, I just took it from the official documentation, okay? And it's all generic one. Even if there is any changes in the version also, no need to worry. This command will be fine. And then we have to apply the changes because we updated the system config file. So the changes, whatever we made, it should be reflecting here. And then we have to download some repositories for container D. And to download that, we'll be using curl command. Using curl, we can able to download this package. So if curl is not available in your Linux box, you can install curl. And using curl, you can able to download this package. It's understandable, right? Or at least you can able to follow, right, what is happening. Okay. So now that we have done with this, and let's update this package. It is going to update for containerd package. What are things we have just downloaded? And then we are going to install containerd. And once containerd is installed, we have to create one directory for containerd explicitly. And then we have to copy the config file to, create a config file under this directory. And this config file will be a copy of the containerd repository, whatever you downloaded. Just let me copy this. Yes. It's done. So now once the file config.toml file is created for containerd, we have to edit this file. Using VI editor, I'm going to edit this file. Go to insert mode and just slide down. And here exactly at this containerd runtime runs the options, you can find this system D C group. By default is false, just make it as true. Because we are going to have a dedicated runtime using the system DC group. So don't worry, just document it here in this page itself. Once you read the file, just scroll down, and at this level, you need to update this to. And once it is updated, save this file, and you have to restart the containerd because it's a config file for containerd. You have to restart it. And once the container is restarted, you can check if it is up and running or not. It's just a quick check. And you can see the process is running for containerd. And then you can able to install the Kubernetes components like your kubectl, kubelet, kubeadm and all. To install these components, we have to download these packages. So use a curl command and download the packages. Once the packages are downloaded for Kubernetes, you can simply update the package and install kubectl, kubeadm and kubelet. Done. So now that we have installed all the important Kubernetes components. So in real-time environment, if we haven't opened all the ports in security group, you have to explicitly run these commands to set up the firewall. So even if you execute now, it won't create any impact because there is no firewall setup done for these machines. So you can see firewall not enabled. So it just keeps the reload. But in real-time environment, this is how we just know enable the access between all the machines. So if it is a master node means you have to implement for all these things, all the port numbers. And worker node means only these two ports are sufficient. All right. And then execute this swap off command to make your kubectl to work appropriately for the deployment. And finally, ensure that you enable kubelet for implementation. That's it. So all these commands should be executed on all the three nodes, right? So I told you all the available nodes. So let's perform the same activity in node 1 and 2. So I think in node 1, we have already installed Docker. And in node 2, also we have installed Docker. All right, so let's start from the containerd installation. This one. So already we installed Docker. So let me start with the step 1 of containerd installation. And similarly download this, update this IP6 tables. And you can restart to enable the configuration. Otherwise, it will get updated after the reboot. So now you can install curl command because curl is not a default package in Linux. So we have to install it in a Ubuntu machine. And once curl is installed, using curl, you can able to download the required repositories and the IO keys. And then repositories, whatever you installed, you just refresh it once and install containerd. So once containerd is installed, we have to create this config file for containerd under a directory called containerd directory. And once it is created, you have to edit the file for that security group. Just go to insert mode and update that system C group as true. Simply save this configuration. And upon this, you need to restart your containerd. And once restarted, obviously it will be up and running. Like if you simply say status, you can able to see it's up and running. Okay. So if you want to know the process ID, then only you need this command, okay, to get the process for containerd, right? And once it is done, you can install the Kubernetes IO keys and repositories. I mean, download the Kubernetes IO keys and repositories first. And once it is downloaded, you can go ahead and install, update the package and install the Kubernetes components. Actually, I've converted all these things as a script. That script will automatically, update create a VA, TOML file and update the entry there also. The system, I'm just converting that false to true, right? So that also can be done through script itself. Because it's very tedious. Okay, in real-time environment, we'll be having hundreds of nodes. We never do all these things manually. So once this is installed, you can update your port, which is optional here, and then enable swap off, and then start or enable kubelet. Okay, So if you look into this, all these things are executable statement and all the non-executable statements are commented here. So if I save this as .sh file and execute the file in this target machine, all the command will get executed automatically. No need to go with a manual approach. Hope you're getting your point. Okay, then let me install Docker. Install Docker. Let's install this containerd. Now this command is installing containerd. And then we'll be creating the config file for containerd. And once config file is created, you can edit that config file to update the system DC group. And finally, you can restart your containerd. And then you can verify the status of the containerd. Because if these parameters, whatever you modified, if it is not proper, then it won't create a task for containerd. So once containerd is installed, then we need to download all the Kubernetes related iOS keys and repositories. And install kubectl, kubelet, and kubeadm. And upon this, if you want, you can run this 3 line of code to update your firewall. That's it. So like this, I'll be sharing this document, okay? If you want, you can able to convert this as script and run it in the target nodes. Don't spend too much time. And now we have configured all the basic prerequisites in the nodes. Now we have to choose which node to be a master. So out of these 3 nodes, if you want to make this as a master means, you need to run the kubeadm init command in the master node. So kubeadm init followed by the pod network CIDR. So as I said, whenever we deploy any pod, the pod will be allocated the unique IP address. So the IP address will be allocated based upon this particular IP range. And this IP range is clearly depends upon the frontal network plugin that you're going to install. And one more important thing is, as the Kubernetes requires a required number of CPUs and memory, since we are using T2 micro instance, this will try to eliminate that error. Definitely this command will throw some issue because your hardware requirement is not satisfied, right? So if any issue that occurs because of the hardware requirements, that can be ignored by using this options. So ignore the pre-flight error, num CPU and memory. Just execute this command. It should be run execute only in the master node. See here, have you noticed? The number of CPUs and memory, the number of available CPUs 1, which is less than the actual requirement. And RAM also it is very less when compared to the actual requirement. But still it is considering it as a warning and proceeding further. It's because of these two arguments. So it takes some time to configure. Yeah, I think it's up and running now. Yeah, so it's done. So you can see your Kubernetes control plane has initialized successfully. Control plane means there is a term used to refer the Kubernetes master. Usually we never call it as a Kubernetes master. It is called as a control plane. And it has been initialized successfully now. And once it is initialized, we have to do some sort of post-installation activity. Means, as I said already, whenever we try to interact with Kubernetes, it is the API server that will receive the incoming request, correct? So the user who submits the request should be an authorized person. He should have access to the Kubernetes. So in order to enable that, we are trying to give access to the user. So these 3 lines of code has to be executed. We are trying to create one directory for that user home directory. And we are copying that config file of Kubernetes to that home directory and change the ownership of that user. So even as a root user, if you want to interact with Kubernetes, you should have that admin config file under his home directory. Then only it can be executable. And upon giving access to the user, we have to run this kubectl apply command to install the frontal network plugins. So these network plugins are used by your kube proxy to enable the pod networking. Correct. So this can be done from this link itself directly. And once all these things are done, finally you can use a kube join command. So this command should be executed in the target machine. If you want to join your worker node 1 to master, this join command, which uses a token, to be executed in target. So first let's preserve this token, copy this, and keep it at the end, that is at the worker node. So this command will be, is the only command that will be executed in the worker node. And now, as part of the initialization, we receive this instruction. So we have to run these 2 lines of code here. So it is already available in document. Just execute this command and have it here. That's it. So let me comment it out. And then we have to run some frontal network plugin. So that command is available here. You can copy and execute this command. So this is a very critical entity. Okay, this will be successful only if you install all these things. Like we were talking about all the prerequisites, no, to have a container ID, container runtime, everything. So only if all these things are successfully defined, your final apply command will try to run the frontal network plugin. So now you can see it's all created related to frontal networks. So using the frontal network plugin, we can able to enable the pod networking. That was the main objective here.
This plugin, we do have this plugin only, Flannel, right?
Yeah.
That we have to install. Okay.
Yes. So it has created, and now that your installation is completed, okay, you can able to proceed with the testing. So if you want to verify the list of nodes, I told you kubectl is a command utility through which you can interact with Kubernetes, right? So if you want to get the list of nodes, you can use a kubectl get nodes command. So as of now, we are Kubernetes master, which is in ready state, and its role is control plane. As of now, we have only one node here. These two nodes are not yet attached. So if you want to attach these two nodes, you have to run the join command, which was generated as part of your kubead init command. Notice here, this kubead init command has generated a command, right? Join command. So this join command has to be executed in this node.
And Sai, is it mandatory we have to configure this machine with two CPU? And because I think it will be chargeable, right? T3 micro instance.
I think I talked about it, right?
Yeah, but actually, is there any alternative that we can have, like, if we want to practice for, longer, then can we do it on some other platform? I mean, not on Ubuntu or.
Actually, no, the basic requirement is you should have two CPUs and 3 plus GB RAM. That's mandatory. But you can able to bypass it by using this parameter, right? I told you. Have you noticed? While giving kubead command, I asked you to use this parameter, right? Have you noticed?
Yeah, pre-flight errors. Okay.
Welcome back.
No, I was not there at a time, so all right.
Yeah, I can understand.
Fine. Thanks.
When you use these parameters, even if there is less number of CPUs or memories available, it just considers a warning and proceed further. That's what I was demonstrating here. So if you see this command in Kubernetes master node, so I gave kubead init command with num CPU error ignore and memory ignore error. So it is just considers a warning and deploying the process. There's no issues. So now that we have a node 1 and 2, which has to be attached to your Kubernetes master. To do that, as part of the kubead init command, it has generated one join command here, kubead join command. So if you look into this join command, it is having the IP address of the node along with the port number and the token. So your Kubernetes master and worker nodes are communicate using the token actually. It's a token-based authentication. And these tokens are automatically generated by Kubernetes, which we'll be using here. So now in this case, simply run this command in worker node 1. And now it's done. See, now it is giving a recommendation. Run this kubectl node, get nodes again in this master node. And now you can able to see it is attaching worker node 1 also. It will be up and running shortly. Similarly, if you run the same command in worker node 2, so this is also successfully completed. And you can able to verify the result here. See here, worker node 1 is ready now. And worker node 2 is getting ready. Easy. So now all 3 nodes are up and running, which is in ready state to deploy our pods. Easy. So point here is, whenever you try to attach your node to work master, this is the IP address. This is the IP address of the Kubernetes master node, and this is a port number 6443. So your master is connecting to port nodes using this port. That's why even if you see here, we are trying to open the port 6443, right? So like this, at each and every level, the port numbers will be used. And there's just a small list, okay? We have a huge list of ports at the service level. So we'll see in the upcoming session. And another important thing is your token. The token, whatever it is generated, right? So it should be saved here somewhere in your inventory. But in the future, if you want to add more nodes, and if the token is not available, means you can generate the token also. So let's say, for example, in this case, I have used one command like kubeadm token create. So at any point of time, if you want to regenerate the token along with the command, you can able to run this command in the master node. See here, sudo kubeadm token create command along with the print join command. You simply say create means it just creates a token. This token will be created. This token you can able to replace in your command like this somewhere here. This one. But along with the token, if you want to generate a complete command, you can able to use print join command. Simply you can copy this and run it in a worker node. Easy. Am I clear with this? Guys, any doubt here? Please let me know. Are we good? Hello, am I audible to all?
Yes, yeah. We are good.
Okay, so I'll be sharing this document. Please have a glance and try to create this. Okay, once you are done with this, then we'll be seeing how to deploy a pod, deploy your containers, and how the pod networking, everything happens practically. So this is about the installation configuration. We are ready with the nodes. So next topic is about the deployment, right? Pod deployment. How we can able to deploy the pods. So in order to understand this,
I
we
think there are
kubectl and pods has to be defined. So first, now let's talk about the pods. Okay, I'm not going to show you any demo now. First, let's understand what is pod and what is pod networking, how the pod IP addresses are created, and what is the kubectl and its associated commands. I'll be sharing only the parameters. So in the upcoming sessions, I'll show you how to implement this. So whenever we talk about the kubectl, I told you it is used to interact with your what do you call that Kubernetes master, right? It is a command line utility helps to interact with the Kubernetes. So in this case, this kubectl command has some properties arguments. So we have something called kubectl command followed by the type of the command and the name of the command and the optional flags. So let's say if you want to create a pod means I can give a command like kubectl create pod followed by the name of a pod which I want to create. And while creating, if I want, I can able to pass some arguments using flags. So like this, these are the commands associated to the kubectl utility. It can be create command, get command, describe, delete, logs, exe, everything. And what type of object you're going to work? Kubernetes has these many types of objects. You can able to work on all these objects by using kubectl along with the name and flag. This is what the property of your kubectl command. Similarly, we have something called pods. So pods are nothing but the atomic unit of scheduling, I told you, right? It's just a terminology in Kubernetes. Like when you're talking about virtual machines, like virtual machines, we have something called VMs, and in Docker, we call it as a container. The smallest unit of task which you want to run in Docker, it will be done through a container. But in Kubernetes, we called as a pod. And how the pods are getting deployed means, whenever we talk about the pod deployment, we have something called API server in a Kubernetes master. So the manifest file, whatever we create, the config file, whatever we create, it will be submitted. The API server will receive the request. Once the request is valid, the schedule will identify the healthy node, and the pods will get deployed in the node actually. So consider this is a cluster we have. Cluster means a collection of nodes. Assume that this cluster is having two nodes. This is node 1 and this is node 2. Correct. And when you try to deploy a pod, the pod will get deployed with the container reference. So each and every pod will be having its own container reference. So this circle can be represented as pod and this block is considered a container. And this deployment can be done at two levels. That means a pod can have a single container or it can have multiple containers. Something like this. It can have a single container or multiple containers. So whenever you try to deploy more than one container in a pod, there will be active container and a passive container in the pod. We'll talk about it. And next important thing is about the pod networking. So whenever we talk about the pod networking, we have two things here. One is interpod communication and another thing is intrapod communication. Interpod communication means, let's say for example here, consider I have two pods, pod 1 and pod 2. And as we discussed already, whenever we create any pod will be allocated to the unique IP address. Right? The pod will be allocated with the unique IP address. And a pod can have a single container or it can have multiple containers. Alright, pod can have a single container or it can have multiple containers. So whenever we create any pod, the IP address of a pod is used for interpod communication. Like if you want to communicate between these two pods, we'll be referring the IP address of the pod. Similarly, we have something called intrapod communication. That is nothing but a pod with multiple containers. It means within a pod, if you want to communicate between the containers, in the case, you'll be using the IP address of pod along with the port number, or you can simply say localhost followed by the port number. So the main important factor here is the pod IP address, which is used to uniquely identify the pod for intercommunication. But for external communication, we can't rely on this IP address. That will be done with the external IP address of the machine, where in which work node the pod is deployed. That node's IP address will be used for external communication. Got it? Is it clear to all? Guys? Okay. All right. So as far as pods are concerned, right, we should understand the status of a pod. So if you look into this, the life cycle of a pod, we have something called pending state, running state, failed or succeeded. So let's say, for example, consider I have a manifest file which defines a property of a pod to be deployed. So when I submit this manifest file, API server will receive the request and it will do all sort of validation and verification. So till it completes the verification, the status of pod will be in pending state. Got it? And upon verification, if it is successfully verified, it will go to running state, or if there is any failure, it goes to failed state. And from running state, if it is successfully executed, it go to succeeded state, or during execution, if there's any issue, it go to failed state. So the status of a pod is very much important to understand the availability of application. So that can be retrieved with the help of your kubectl get pods command. Kubectl get pods. This is what the command which will get the status of a pod. It will get you the name of a pod and status. All right. So this is about the pod's life cycle. So I'll do one thing. I'll just show you a quick command reference. Okay, here in this machine. So if you simply say kubectl get nodes, you can able to get the list of nodes, right? Along with the status of the nodes. Similarly, there is a command called kubectl get pods. See here. As of now, there is no resource defined in the default namespace. So namespaces are considered the logical partitioning of a cluster. So we have various namespaces which are predefined, and as per the application needs, we can able to create the namespace also. So as of now, we never create any pod. That's why it is saying no resource found. But in future, if we create it, it will be available in the default namespace. But if you want to explore the system pods, you can use a parameter like --- all namespaces. It means I want to retrieve the list of pods from all the available namespace, not just from the default. So in this case, you can simply use the parameter --- all namespaces. So now you can see these are the pods that are running like kubectl network plugin pod, core DNS, etcd, API server, controller manager, proxy, kubeproxy scheduler. Hope you remember all these things are Kubernetes components. And all these components are running in the Kubernetes default or system namespace. That is called as kube system namespace. And for frontend network, it is having using kube frontend namespace. Like this, tomorrow, if you try to deploy any pod, the pod will be deployed in the default namespace. So once the installation is completed, if you're saying like you're successfully configured Kubernetes cluster means when you issue your kubectl get pod from all namespaces, all the pods should be up and running. Series should be up and running. If there is any issue in the core DNS or funnel network or any other thing, there is some issue with the installation, you have to revisit. All right. Any question? So I'll be
Sai, is that mandatory that when we create a pod, so it will be having some specific namespace, or is that okay if we don't give any namespace?
It is optional. Namespace is optional, but as a best practice, we deploy a pod in the specific namespace.
Okay.
I'll talk about in the once we create a pod, I'll show you how we can able to allocate in a specific namespace and all.
Yeah.
So any question, please let me know. What is it? Sat is not satisfied at all. Thanks for that. Any questions, guys? Please let me know. Guys, am I audible to all or what's the problem?
Sai, one more query. As we discussed, in the beginning of the Kubernetes, so there is a pod, right? And we have more than two containers in a pod. So let's say if someone wants to access that service, I mean application in the container. So is that possible through the browser, or we have to use this CLI command?
It is possible through browser. You can do that. That is the reason, right? In Docker, we learned about
port
port
mapping.
mapping.
Yeah,
Remember?
yeah. So exactly
Similarly,
the
here
same way.
will be here we'll be using a service like a node port service through which we can able to handle it.
Okay.
So guys, any questions? So for today's session, ensure that you are understanding the concept behind Kubernetes and all its components, and try to install and manage the Kubernetes master and worker nodes. If you have any questions, please let me know. Because I'm not sure how many of you are available online now.
We are just 6 only.
Are you guys able to manage the session, or you want me to route it to someone? Right? It's okay, right?
Yeah, it's good.
All okay, so I'll just open it for your Q questioners. If you have any questions related to previous modules or any doubts related to your demo or live practice, please let me know now.
If we want to integrate this Kubernetes in Jenkins, so I mean we have to do the same way like we did in Ansible.
Yes, so how you configure QA server and attach to your node, right? The
Nodes,
same
yeah.
manner you can able to do it.
So
I'll show you. I'll show you a demo of that. Don't worry. Next session, right? I
yeah,
think next we have two more session, right? 28th and 29th is last day, right?
yeah.
Okay. So in the next session on next Sunday, I'll show you a demo of how to integrate this. I can show you a end-to-end pipeline which can automatically build the application and deploy it to the Kubernetes cluster.
I mean, I just want to know the steps would be same, right? That we did for Ansible.
Yeah, that's
Oh,
right.
okay.
Uh, Please let me know if any queries, even from previous module, if you have anything, just let me know. Ansible, Terraform. Okay, let me update this document for you. What is that report? Is um, Okay. First, let me update the notes, class notes, and then I'll be sharing this in your reference list. All right, guys. So documents are up to date. You can refer it and make use of it. Okay. Thank you. Yeah, no problem. Any questions? Are we good?
Yes.
Okay. If you have any questions, please let me know. You have enough time. Yeah, no problem. Thank you.
Thank you, Ranjan.
So we are done today, Sai.